6D is all about capacity. So capacity of a container is the quantity of fluid that the container is capable of holding. So think of like a 2-liter bottle of Pepsi. We don't say, oh, it's 2,000 cubic centimeters. We don't talk about its volume. We say how much liquid can go into the container. So just the difference between volume of a container and capacity, and we can go back and forth. So this, you need this key. This will be the key to converting back and forth. It's going to kind of feel like a science class for this lesson just because it's all about conversion. Another thought that I thought was interesting, 3 lines here for IB means equivalent to. And when you are talking about liters, we can either convert to centimeters cubed or we can go to meters cubed. You have options, but you need this key for the next couple of problems here. Now, like I said, we have options if it's in terms of liters. And so, let me get my papers here. When we do 9.6 liters, I want to convert it either into cubic centimeters or cubic meters. So I'm going to show you both. And there's going to always be one that makes a little bit better sense. So if I want to do liters, I always put liters on the bottom. If I want to turn it into cubic centimeters, there are 1,000 cubic centimeters for every 1 liter. So I always need to alternate the units I'm going to cancel. So I can cancel my liters and I'll be left with cubic centimeters. Now you're just always going to multiply the top. And let me just show you this whole thing here. 9.6 times 1,000 is 9,600 cubic centimeters, technically divided by 1, so it's just 9,600 cubic centimeters. So you multiply across, you're multiplying this way and dividing by the number on the bottom. Okay, now, what if instead of cubic centimeters, I wanted to convert 9.6 liters to cubic meters? There is 1 cubic meter for 1,000 liters. Notice I always put my units to cancel. One is on top, one is on bottom to cancel out. Multiply across, and I get 9.6 meters cubed divided by 1,000. So you multiply across, divide by the bottom because it's like a fraction. And then we'd go, if anytime you divide by a fraction, you go 1, 2, there are 3 zeros, and we're just filling in those spaces. So when we talk about 9.6 liters, we can either say there are 9,600 cubic centimeters, or we can say there are 0.0096 cubic meters. So I would say this makes more sense, but either one would be correct. Sometimes you just want to pay attention to your directions to figure that out. All right, now I'll do letter B. If we start with 3240 liters, I'll have the 1 liter to my 1,000 cubic centimeters. My liters cancel. I'm going to multiply my numbers across, divide by 1. When I multiply by 1,000, I just add 1, 2, 3 zeros, and I'm left with that many cubic centimeters. Or I can change it, instead of cubic centimeters, I can multiply by 1 cubic meter over 1,000 liters. My liters cancel. When I multiply by 1, divide by 1,000, I'm just moving my decimal back 3 spaces, 3.24 cubic meters. So in this case, I think this number makes more sense to convert it to cubic meters. The numbers are just a little bit more viable. Okay, I think example 9 would have been helpful if it would have called it a rectangular prism, because then I know that my volume is length times width times height. And always look at your units. They should always be the same units. So 2.6 times 3.1 times 1.45. So in order to find capacity, first I have to find volume. Very important. All right, so I get, when I multiply them all together, I get, and because it's really meters times meters times meters, that's why it's cubic meters. And if we go back, cubic meters, I can either do 1 cubic meter is 1 kilometer, or 1 cubic meter is 1,000 liters. To me, the 1-to-1 correspondence is much better. That means for every one of these, this is the same measurement as a kilometer. It's equivalent. Cubic meters is equivalent to 1 kilometer. So if I have 11.6787 meters cubed, I also have 11.8687 kiloliters. So this is our volume. This is our capacity. The units determine volume or capacity. All right, this last one can be just a little bit different. So it says this much rain falls on a flat rectangular shed roof. Now, what's kind of weird to me is it's like the shed is, the roof of the shed is, let me move that over a little. It's kind of like a rectangular prism roof. When the rain fills the roof, so think of this as like filling the roof, and then it's almost like it's draining into a cylindrical tank. So then it's filling up my tank. But first it fills the roof and then it drains into it. Okay, so the length of the roof is 10 meters and the width is 6.5. Notice these are in meters and this is in millimeters. So the first thing I need to do is convert my 17.3 millimeters into meters. So I want millimeters to be on the bottom, meters to be on the top. The nice thing about metric is they're all powers of 10. This is 3 spots away from meters. So I have 1,000 millimeters in 1 meter. Millimeters cancel, multiply across, divide by 1,000. So I'm just moving my decimal 3 times. So 17.3 millimeters is the same thing as 0.0173 meters. I have to have this in meters because my length and width are in meters. So my units all need to match. So then I can find the volume of the rain that fell into the roof. 10 times 6.5. When I multiply them all together, I get this many cubic meters. Now, once all of the rain drains into my cylinder, what they want to know, so this falls, how tall is this? How tall is the water in the cylinder? All right, first of all, it tells me my radius. Well, it says my diameter is 4, which means my radius is 2. So the volume of my cylinder, pi r squared h. So the volume of water that's in the cylinder, all this rain drained into the cylinder, so it's the same amount. Oops. The volumes are the same, so I can replace this volume in place of this volume. My radius is 2, pi squared is 4. Now I'm just solving for the height of my, so I'm going to divide by 4 pi to get h by itself. And when I divide these numbers by 4 pi, I get 0.0895 meters, because everything's in meters now. But it says, anytime you go through and solve a problem, always go back to the question. By how many millimeters did it rise? So if I have this many meters, how many millimeters is this amount? So I'm now going to convert my meters into millimeters. So I put meters on the bottom so they cancel. In 1 meter, there are 1,000 millimeters. So when I multiply my numbers together, I'm just going to move my decimal 1, 2, 3 times. So this many meters equals 89.5 millimeters. Final answer.